Okay, welcome back everybody to day 2 of the AP Computer Science A live lessons. Today is 9.2, writing constructors for subclasses. For those that are joining us for the second day, welcome back. We're glad that you enjoyed yesterday enough, or at least got enough out of yesterday to come back and see us a second time. And for those that are joining us for the first time, welcome. We're glad that you could join us today. My name is Rob Schultz. I teach computer science classes at Bellbrook High School in Bellbrook, Ohio.
I'm Jill Westerland. I teach computer science at Hoover High School in Hoover, Alabama. And we want to give you a little background information about our course, our exam sessions that we're leading. And we're going to start with letting you place yourself kind of in our map where we are related to where you are. And you may not even be in the United States, and that's just fantastic. We're going global. But if you are in the US, you can see that Mr. Schultz is in Ohio and I'm in Alabama. So we don't know where you are, but wherever you are, we're thankful that we're able to provide this opportunity, and you're our priority during these days. We're on day 2 of 28 days of exam review. You're our focus during this time, and we're very privileged and thankful to be able to stand in the gap for your teachers during this time. Yesterday, I noticed from the kids who worked on homework or worked on the Google Drive resources, we had people coming from Virginia and Baldwin County, Alabama, and Georgetown and Austin, Irving, all over the place. So I'm real excited at all the people from everywhere who are participating in exam review. So we want to go over what we're going to be teaching over the next few days before we really begin a series of repeating exam prep. Here's what we know about this year's 2020 AP exam for Computer Science A. There's not going to be multiple choice. There will be no questions from Unit 8, 9, and 10. The free response questions that we'll see for you to be assessed upon will be from Units 1 to 7, and I'm going to unpack those units briefly in just a minute. The exam will be 45 minutes. It'll be free response only. We're all going to know more about it on April the 3rd, so we'll all be watching for then. The reason that we're starting with Unit 9 and 10 is because the AP program has assured colleges that a student who gets a qualifying score and therefore would get college, CLEP credit for the Computer Science A course has been instructed on certain topics. And those topics include Units 9 and 10. Unit 9 is about inheritance and Unit 10 is recursion. Both are vital topics for a student to understand. So over the next 8 days, this being 2 of those 8, day 2 of those 8, we're going to be covering inheritance. Tomorrow we'll finish inheritance. And then on Monday, we're going to move over to array list, but we're going to be using an array list, hopefully that's a part of one of your inheritance projects that you've thought about or worked on. Then next week, we're going to migrate to recursion, applying some recursive methods to the array list that you create. So Mr. Schultz and I have worked hard to try to develop some materials that we think that you can grab onto. So let's take a look at the big picture of the Computer Science A course. And students, this may be new graphic to you. It won't be new to your teachers. The course and exam description lays out the course in 10 topical units. And like I said, we're starting in Unit 9 yesterday, today, and tomorrow. If you didn't watch yesterday's video, I hope that you go back. You'll probably want to after today, after you see the extension of the examples. Then we're going to work on Unit 7 on Monday and Tuesday as we kind of jump back to prepare an array list. Then we're going to move forward to recursion at the end of next week. After those 8 days, we're going to go all the way back to Unit 5 and methodically come forward very strategically and topically over the next, that would be 4 weeks. Yes, 4 weeks of exam review, writing classes, one-dimensional arrays, array lists repeated. Then we're going to go to string. We're going to spend a week on strings, and we're going to also weave in conditional statements and iteration throughout all of that. So those will be important weeks for you, just like these units are important. You may hear a presentation about inheritance that's a little different than your teacher presented it, and you may learn something that you didn't catch the first time. So that'll be great if that's the way that it works. We're going to be releasing a calendar schedule of all the lessons that we're going to be doing, and maybe next week or so. And that will be helpful to you, I think, as you plan your days. So it's time now for today's lesson. Mr. Schultz, take it away.
Did you want to go ahead and go through the warm-up from yesterday first?
I can, yes.
Okay.
Happy to.
Right.
So let me go back, I guess, well, not back on a slide, but yesterday I gave y'all a power up. And we're going to call power up homework, because in gaming, power up means that you're getting an advantage or new skill, new set. So I asked you last night, or we did, to look at an inheritance topic. I gave you some resources for that. If you weren't here yesterday, you'll notice that we have a bit.ly link to a Google Drive that is shared. You do not have to have edit rights to that Google Drive. You just need to view it. I wanted you to think about a 3-level inheritance relationship of some topic. And I pitched one topic about animals, but I also provided a link to a whole bunch of other topics. And then go ahead and go to the next graphic. Go ahead. Yeah. Here's the topics. Yeah, that's fine. Here's the topics that I linked. So you have this in the Google folder from yesterday. So if animals don't jazz you, you might want to think about superheroes and Marvel versus DC, and then categories under that. Cars may be your thing. Disney princesses may be your thing. Careers, cats instead of dogs may be your thing. So you can make an inheritance diagram to practice your skill of the concept of a hierarchy with any topic that is relevant to you. Media is another one. So hopefully last night, or maybe this morning, you spent some time on paper thinking about classes that might relate to each other. What would be your superclass? What would be your subclass level 2? And what would be your subclass level 3? Some vocabulary from yesterday. We talked about inheritance has an is-a relationship. Composition is a has-a relationship. Polymorphism means that we can make many forms of an object of a particular type. Superclass, subclass, use of the keyword extends, and then constructor method. And we'll talk more about those words again today. You may have taken some notes from yesterday. I took a picture here of my little notebook that I'm taking notes in to kind of think through the topics as we come to them. I really do want to encourage you every day. You'll probably get tired of me saying it. I might stop saying it, to begin to write things down. Hopefully you found a notebook. If you're new with us today, we would love for you to find a notebook or some paper and create your own set of concepts related to the lessons that we do. Remember that your assessment is going to be paper pencil. So it's important that you become comfortable over these weeks of writing code by hand. We're going to be course focused on the units that I laid out in that large graphic, concept based. And our primary goal is for you to be really comfortable handwriting code and then testing your code secondarily. So we'll give you a lot of resources for that. And I'll be back after the lesson to talk about the things that we'd love for you to work on tonight. So now it's time to start today's lesson.
Okay. All right, here we go. So the topic for today is an extension of what we talked about yesterday, no pun intended. We're going to start looking at creating constructors to go into the subclasses and superclasses that we started putting together in our hierarchy. So prior knowledge would be the ability to create a class. Hopefully you've had some experience creating classes at this point, creating a constructor method and understanding really what the purpose of the constructor method is. There are different types of methods, and the constructor has a very specific purpose. And prior knowledge would be actually implementing a hierarchy of classes. So if today is your first day with us, if you haven't had any experience in implementing classes, you might want to go back and make sure that you watch the lesson we did yesterday so that you understand how to build a hierarchy before we start actually creating the constructors that go into the subclass and the superclass. The goal today is to learn to create overloaded constructors in a subclass, create default constructors in a subclass, and we're also going to talk about the purpose of the use of super in a subclass. So let's jump in. So first thing I would like you to do, we're going to do a 2-minute kind of prep activity so we have some things to talk about. This is our dog class that we had yesterday that we worked with. I've got 3 private instance variables. I've got string name, int age, and double weight. And I would like you to take 2 minutes and complete both of the constructors. We have a constructor with an empty parameter list that we're going to call our default constructor. And then I have a constructor that takes a string, an int, and a double as parameters. So take 2 minutes. I'll check the time here on my stopwatch, and I'll give you a 2-minute go. And then after you've had a chance to put the constructors together, we're going to go over a little bit of vocabulary just so that we're all using the same terminology as we go from here. So on your mark, get set, go. Yesterday, I had said I would find music, and I didn't do that. I was tempted to just hum something, but I don't think anybody wants to hear that. I saw in an email yesterday that in one of the other live topics, during a 2-minute break like this, the teacher that was presenting was actually dancing for the students that were watching.
Wow.
And I know nobody wants to see that. I don't know about you, Mrs. Westerland, but yeah. I have no moves.
We could set up a camera on the dogs and see what Bo and JJ are doing during our 2 minutes.
We could do a JJ.
Bo's taking a nap, I'm sure.
All right, we've got about 1 minute left.
The dog cam.
I was hoping JJ might join us today, but she hasn't poked her head in the room yet.
I think next Friday they should make an appearance.
Yeah, that would be fun.
Or every Friday, maybe tomorrow.
Okay, we're at about 30 seconds left, so try and bring things to a close if you haven't already. Okay, I'm going to call time. So this is what I came up with. Now, the constructor on the top with the empty parameter list. If I can get my mouse over here. This is our default constructor. And as we go through this, I'm going to kind of work through a little bit of vocabulary. We call it a default constructor because if you look down here in the bottom left corner of the screen, if in our main method we instantiate a dog object and we don't put any information in the parameter, in the parentheses, if we don't give a parameter in the parentheses, then by default, our dog that we instantiate will be named Bingo, age will be set to 4, and weight will be 20.5. So those are our default values for just any generic dog that we are asked to create with no information about the dog. So that's why we refer to it as a default constructor. It's our default go-to constructor if we have no information to work with. The other constructor is our overloaded constructor. And for those that haven't heard the term overloaded before, overloaded just means that I have multiple methods in the same class with the same name, but different parameter lists. So I can overload any method I want. In this case, we're overloading constructors. I have a constructor with no parameters. I also have a constructor that takes a string, an int, and a double. So looking again down in the bottom left corner, when we instantiate our object D2 for our second dog, we're specifying that we want the name to be JJ, we want the age to be 9, and we want the weight to be 38.5. Okay, just some other terminology, again, to make sure we're all on the same page. You'll hear in object-oriented programming references to client and server objects. Anytime 2 objects interact with each other, one is the client, one is the server. In my own class, I use the example of if I go to the bank, okay, I am a customer object, the bank teller is the bank teller object. Well, I'm the client and the bank teller is the server. And as long as I understand what the server's behavior is, the list of methods that the server has available that are public that I can access, You know, I'd like to make a deposit. I'd like to make a withdrawal. I'd like my account balance. This is a stick up, and my kids always chuckle when I say that one, but that's actually a behavior that the bank teller has instructions to follow. So that would be a legitimate method for a bank teller. If I would walk into the bank and say bank teller dot cheeseburger and fries, that's not part of the behavior of that specific server object. So I'm kind of going off track a little bit with the idea of client server, but the basic idea is that if I have two objects that are working together, one is the client, it's the one that gives instructions or tells the server object what to do. Down here in the yellow where we instantiate our two dog objects, if I later go on and say d1.sleep or d2.breathe, those would be commands that come from the client telling the server objects what to do. So any of our dog objects would become server objects. They follow the instructions that are given in the client. We have formal parameters and we have actual parameters. So formal parameters are over here, any place that I'm formally declaring what the parameters are for a method. I'm formally saying that I need a string, and then I'm formally saying I need an int, and then I'm formally saying that I need a double. And in my own class, when I present this, my students get tired of me saying the word formally, but I repeat that as many times as I can so that they get the idea that I'm formally defining what those parameters are in the method when I create the method. When I look down here in my client code, I'm looking at actual information that I'm passing into those parameters. So I'm passing in an actual string JJ, an actual int 9, and an actual int 38.5. There's nothing being formally declared down here. I'm not specifying a string, an int, or a double. I don't have to put those keywords in here anywhere because this is where I'm giving actual information that go to the formal parameters. So that's our difference between actual parameters and formal parameters. And then the last one I wanted to hit, because it kind of ties back to the idea of the purpose of the constructor, every object has a state. You know, I as an object sitting here have a state. Right now I'm sitting, I have my name, my age, my weight, I have my location. I could give you my latitude and my longitude and my elevation. In 5 minutes, my state could be entirely different. I could be in a totally different location. I'll be slightly older. I might have a slight fluctuation to my weight at some level. 12 hours from now, my location will be different. I'll probably be sleeping instead of sitting. So just like people have a state that changes, our objects have a state that changes. And when we create a constructor, the idea of the constructor is to set the initial state of our object at the point that the object's instantiated. So when we refer to state, we're talking about the state of the object, and we're talking about the contents of its properties at any given point in time. Okay, so that's our vocabulary lesson for today. Let's move on to some new stuff. I wanted to start this part off by saying that we are covering, when it comes to inheritance, we're just barely brushing the tip of the iceberg. You know, there is a lot of information that goes with inheritance in object-oriented programming, and we're giving just the highlights in a 3-day period. So that being said, I wanted to kind of step back quickly and mention the object class, because no discussion of object-oriented programming and inheritance would be complete. I would be failing you as a teacher if I didn't at least throw in some reference to the object class. So I know our time is short. I know we've only got 3 days to get through the specific topics, but I wanted to make sure to at least make reference to the object class. Whether we know it or not, ever since we wrote our first Hello World program, we've been using inheritance, because every class that's created in Java, if it doesn't specifically have an extension, like our Basset Hound extends dog, if we don't specify another class for it to extend, then by default, it extends this object class automatically. And the purpose of the object class is to give us some basic methods that we can use within the objects that we have. So for example, the object class includes a constructor, it includes a toString method, it includes an equals method, it includes some others. And it's kind of important to point out that if I ran our code exactly as it is right now with no constructor in any of these, then our constructor would be pulled from the object class. And what the constructor in the object class does is it basically says any numeric properties automatically get set to 0. There we go. Any numeric properties automatically get set to 0, and any object properties, including strings, get set to null. So if we hadn't just created our own constructors for our dog class, then we would automatically inherit this constructor for any dog or basset hound or mixed breed that we create. Name would automatically be set to null, age would be set to 0, and weight would be set to 0.0. I really wish we had more time to talk about the object class and what the toString does and equals, but again, our time is a little limited. I did at least want to make a reference to it. Okay, so if you get a little time, that might be something to Google. You know, what does the object class in Java really do for us? Okay, we are going to jump over to the class that we just worked on, the dog class, with our 2 constructors. And we're going to start with the overloaded constructor. Now, if you look at the code I've got up here, Basset Hound, Hound equals new Basset Hound, and then we do system.out.println. For those that were with us yesterday, you'll recognize that. That's the code that we ran to test and make sure that everything would work, even though our Basset Hound class is literally an empty class. There's nothing there. When we run this code in our client, it's going to go over and it's going to check the Basset Hound class for a constructor. And because there's no constructor there, it's automatically going to go to the default. It's going to set name to bingo, age to 4, weight to 20.5. And then when we call the toString method, which is down here with these other methods, it's going to display the state of the object. It's going to tell us that name is bingo, age is 4, and weight is 20.5. And we ran that yesterday. We know that that code works. Okay. So now we're going to expand on that a little bit. And we're going to do this in our client. We want to create another Basset Hound object called Hound1. And this time we want to use the properties bow, 7, and 35.4. Now, I'm not a Basset Hound owner. I don't know if 35.4 is an appropriate age for a Basset Hound. That was a total guess, so sorry.
No, it would be twice that. He weighs like,
twice that?
Well, close. He weighs like 60 pounds. We should have him on a diet, but he's not.
All right. We'll say our Basset Hound, Hound1, is a 7-year-old baby Basset Hound.
That's good.
Okay. So at this point, when I plug this into my client, when I plug this into my tester in the main method, and I go to run this, our assumption would be that it's now going to come over and it's going to use our overloaded constructor and pass bow into N, 7 into A, and 35.4 into weight. But when we actually go to run it, we get this. Ooh, there's a typo on my slide. Sorry about that. We actually get that constructor Basset Hound in class Basset Hound cannot be applied to given types. Well, the reason for that is in Java, in a subclass, if I don't include any constructors at all, then the compiler takes that as a sign that we really want to use just this default constructor. So as long as my constructor that I call has no parameters and I have no constructors in the subclass, then by default, it'll pull the default constructor from the superclass. But now that we've given it specific information, Java is going to make us be specific. And it's essentially telling us, you're looking for a Basset Hound constructor with 3 parameters, and you have no constructors in the Basset Hound class. So what we need to do is we need to write an overloaded constructor that matches the overloaded constructor in the dog class so that we can pass that information to it and kind of make a, like a fire brigade, like a bucket brigade type situation, okay? So we're gonna do this. All right, so as you can see, what's gonna happen, we're now saying that we're gonna create a separate constructor in Basset Hound that takes the same 3 parameters that I have up here. I'm gonna give it a string, an int, and a double so that it matches the parameters that I'm giving from the client. And then I mentioned the Bucket Brigade, and for those that don't know what a Bucket Brigade is, that was a way back in the old days, even before our time, of trying to fight fires. If you had water that was here and fire that was here, you would have a group of people that would line up in between with buckets, and you would pour water from one bucket to the next to get it to the fire. Well, this kind of works the same way. We're taking bow, 7, and 35.4. We're passing it down to the Basset Hound constructor in A and W. Then we're taking that information and we're using this call, which I'll talk about in a second, to pass it up to the super constructor with the same 3 parameters. And then from there, we pass it on to name, age, and weight. So we're kind of passing it from one spot to the next to get everything where it's supposed to go. This reference to super, what super does in a constructor is it basically says to jump one level up the hierarchy and call the constructor in the superclass with matching parameters. So by specifying that I'm looking for super, a string, an int, and a w, which is what N, A, and I'm sorry, a string, an int, and a double, which is what N, A, and W were specified to be, I'm now saying I want to take that information and pass it to a constructor in the superclass that has the exact same parameter lineup. Hopefully that makes sense. Okay. So now let's take another step backwards and let's look at our default constructor again. So a second ago, before we added this constructor, we ran pretty much this exact same code, except that we called it Hound instead of Hound 2, and everything worked fine. So again, we would assume that because it worked before we added this constructor, that it would work after we add this constructor. But when I add this to my program and I run it, we get another error message. Now it's telling us constructor Basset Hound in class Basset Hound, again, cannot be applied to given types. Well, the problem is that the compiler now has a method, a constructor, in the Basset Hound class. So again, it's going to make us be specific. Now that we have something in here, it's not going to let us automatically jump up to the super default constructor in our dog class. So because I have a constructor in here, I now have to add a basic default constructor in the Basset Hound class. So generally the rule is once you include a constructor in a subclass, you must also include a default constructor in the subclass if you plan to use one. Our program ran perfectly fine with the 3 parameters. And if all I ever plan to do is pass in 3 parameters, then we're great. But if at any time I plan to use this default constructor, then I have to have something in the Basset Hound class that'll let us pass the information, or that will actually call it from the Basset Hound class. So again, because I'm calling the Basset Hound constructor, somehow I have to tell it that I want it to actually run this constructor. So all I have to do is put in a call to super with an empty parameter list. Just like we did down here, instead of looking for super with a string, an int, and a double, it's going to look for a constructor that has empty parameters. So it's automatically going to run this one. It'll set our name to bingo, our age to 4, our weight to 20.5, and when we hit our toString method, that's what we'll display. So general rule is if you include an overloaded constructor, you also have to include a default constructor, provided you plan to use the default constructor. Okay, hopefully that wasn't confusing. All right, so let's do a quick check for understanding. All right, I'm going to kind of refer back to the case study a little bit. And I want you to imagine now that we've got our dog, our Basset Hound, and mixed breed hierarchy that we're now tying into this overall animal hierarchy. We have an upper level part of the hierarchy, animal. Below that, we have domesticated animal and wild animal. Below domesticated, maybe we have dog, cat, parakeet. Below dog, we have our Basset Hound and mixed breed. But I want you to look at this branch over here. There we go. We're gonna actually set up the constructors for our animal, wild animal, and hippo classes. Okay, so here's what I would like you to do, and I'll give you, it's going to be a lot of quiet airtime. Maybe I will hum, I don't know. I would like you to set up the constructors for our animal class, wild animal class, and hippo class. Now, notice that our animal class has 2 properties. We have a string scientific name, and we have a string common name. And what I would like you to do is write the constructors that would be necessary for the following lines of code to compile correctly. I want to create a hippo, H1, as a new hippo with the default constructor. And then I'd like to create a second hippo, an instance of the hippo class, H2, where we pass in the parameters hippopotamus, amphibious, and hippopotamus. Okay, so take a couple seconds and think about what that's going to look like to pass from one level up to the animal class. I'll give you about 5 minutes and then we'll come back and regroup and take a look. Okay. All right, on your mark, get set, go. I really am tempted to hum.
Good. Every 30 seconds, you can give a hint.
Okay. All right, so I'll go ahead and give hint number one. Remember that at some point, at least one point, we're going to have to make a call to super. I'm not very good at giving hints. Sometimes my hints give too much away.
That's good. I could ask a question. That would be the hint.
Okay, the second hint is that you might have to use super in a couple different ways. I'll wait till the halfway point for the next clue.
That's right. It's like Hansel and Gretel. We're leaving breadcrumbs.
Uh-huh. Yeah, we really are going to have to get creative and come up with something to fill this dead.
I'm going to get Mark Emery in Austin, Texas, CSA teacher and cybersecurity extraordinaire to send us some music.
Okay, all right. I have a couple of students that are working in EarSketch right now on a project because it's easy to access from home. So I thought I might try and have them compose a little
get them to
ditty for us in EarSketch.
code us some music.
Yeah.
Some of you watching, code us some music in EarSketch and send it to my email.
Oh, that'd be great.
Yeah.
Yeah. Just a little sidebar. If you've never used EarSketch, it's really a lot of fun. It's Python. It's not Java,
but we're okay with that.
Yeah. Okay, I think we are at the 4-minute mark.
So you should have 2 constructors written.
Mm-hmm. And then think about where those two, the code for the 2 constructors would be and what you would need in the other 2 methods. And we've got about 30 seconds left. That seemed like a fast 5 minutes.
I saw a hippo one time at the Hasasuma Wild Animal Park outside Tampa, and it had been a hippo in the movies.
Oh, cool.
They would toss, it was in a big pool lake kind of thing. It's a really cool park in Florida. And they would toss it watermelons, and it would eat the whole watermelon.
Wow.
Well, here
in Ohio, Fiona is our celebrity hippo at the Cincinnati Zoo. Okay, that's our 5 minutes. So here is what I came up with. Okay, so think about this for a second. At the upper level, in the animal class, we want our actual constructors, the coded constructors, to be in the same class where our properties are. So I have a default animal constructor. I couldn't come up with a good scientific and common name, so I came up with Animalus genericus and generic animal for our scientific name and common name. And then I also have an overloaded constructor where we ask for a string and actually 2 strings, S and C. We set scientific name to S and we set common name to C. So if you look down at our client code where I instantiate hippo H1 with our default constructor, well, that's going to call the default empty constructor in our hippo class, which immediately makes a call to super. Super goes up 1 level and calls the constructor with an empty parameter list, which then calls super. So it's going to go up another level to here, and it's going to set scientific name to Animalus genericus and the common name to generic animal. Okay. If we go back down to our client code again and we instantiate hippo H2 with the parameters hippopotamus, amphibious, and hippopotamus, hippopotamus, amphibious, and hippopotamus get passed to hippo that asks for 2 strings, which then immediately calls the superclass that takes 2 strings. So we're basically passing those 2 strings to parameters S and C in the wild animal class, which then immediately turn around and call super again with the same 2 parameters. So it's going to jump to the animal class. So now in the animal class, parameters S and C get set to hippopotamus amphibious and hippopotamus, which are then used to set the scientific name and the common. So hopefully everybody got that, and we are looking good. Okay. That's it. That's as far as I wanted to get today. I think that's plenty of information for us to sort out. So let's do a quick debrief and summary. The 3 main points I wanted to make today. If there is no constructor in the subclass, the object will be instantiated using the default constructor in the superclass. The second point is once you add a constructor to the subclass, then you also need to add a default constructor to the subclass. And I should have thrown in a little caveat, if you plan to use it. If you don't plan to use a constructor with an empty parameter list, it really doesn't need to be there. And then the third point, super can be used to reference a super constructor or a constructor in the superclass, provided that you're making sure that you match the required parameters. Okay, so those were our main points today. Hopefully everybody was able to follow along and everything made sense. So I'm going to move on to our power up.
Okay, so we have, again, the Google folder that you should be able to access with this bit.ly link. And remember, it's case sensitive. And I know a lot of you found it yesterday, so that's really exciting for us to think about. What I learned since yesterday is that we can use JDoodle, and I have built out the dog project in JDoodle for you. And I've also put the animal constructor sample. So some of this Java code that you're seeing here, which would be in today's folder, there's actually now another document. I named it with an exclamation point so that it would be at the top of the list so that y'all would be able to find it easily. And I'm going to keep a running list there of JDoodle code links. So in other words, you're going to pick up my JDoodle project that I built out with Mr. Schultz's dog project class. So it has the tester, the Basset, the mixed breed, and the dog. So you'll be able to play around with that code. You could rewatch yesterday's video. It's at the state that the code would have been in before today's lesson. And then the other things that are there, I built out the animals. So you've got some code to kind of work with as you go through and begin to think about a project. And there might be one more slide, Mr. Schultz. Let's see if there is.
Here we go.
Yeah. So what I would love for y'all to work on tonight is extending what you might have designed yesterday. And if today's your first day joining us, then welcome. Obviously, we're thrilled that you're here, but we want you to begin to put together a hierarchy and a class program of topic of your choosing. If you like food, make a food project that extends to different food groups and then maybe recipes that would be under that. So like I said before, if you're into superheroes and all the Avengers movies, and I know nothing about all that really, so you pick your thing and run with it, because you're going to become more versed in inheritance as you experience it, whether you're writing the code and designing it or whether you're actually coding with it. The great thing and we have Miss Romchek from Dallas ISD who texted me yesterday and then called me last night, and she and I had a Zoom this morning and kind of got me up to speed on all the capabilities of JDoodle. I just did not know that JDoodle had kind of grown up. I thought it was just an easy little browser to use, but they've actually done lots. So those of you who have only a cell phone at home right now, you can JDoodle on a cell phone. If you have tablet, JDoodle on tablet. If you're a Chromebook, if your school's one-to-one with Chromebooks or you own a Chromebook, you can use these projects on your Chromebook. So you'll find resources for that now in the share drive. And I'm going to keep doing that as we go forward, because I want to do everything that we can do on our end to make it as easy as possible for you to learn at home and get your experience ramped up in Java. So today's power up is for you to go one step farther. And work with a project of your design. Here's a media version. I use sticky notes so that I could kind of lay it out, think about my variables that I would use. It gets big quickly, so you may want to scale back and not have so many variables. This was more of a brainstorming list than an actual coding list. But you can see the yellow notes at the bottom. That's where we're heading on Monday. On Monday, we're going to be making an array list from one of your classes. You can have any topic that you choose. So there again, it would be great if you pick something that's of interest to you. And I'll make you up some sample ones, but that's kind of where we're going with this, is to build some array list off of a class. And then we're going to do some things next week with array list. Tomorrow, we're going to be talking about overloading versus overriding. The official topic for tomorrow is overriding methods or overridden methods that are used in inheritance. So we hope that you come back tomorrow and work with us to go one step again into inheritance and thinking about inheritance and using the power of object-oriented programming to build classes that interact with one another, because our programs are small because that's the scope that we're working at. But you can imagine large corporations, how their programs depend on this hierarchy so that they can reuse code. Because remember, the purpose of inheritance is to be able to reuse code, not start from scratch and cause things to interrelate. So we've got a new slide today from College Board that we want to share with you. If you have a device issue, an internet issue, device issue, there are companies who've come alongside College Board and want to help you become equipped to be successful in computer science during this time. So we would like for you to reach out to College Board, cb.org/tech, and let them know how that you can be supported from wherever you are. We are so happy that you're with us today. We hope you come back tomorrow where we go to lesson 9.3.
We are going to keep moving right along. So yeah,
Right.
keep coming back for more.
We'll be here.
I hope you are all watching this, enjoying it as much as we have. I mean, this has really been a lot of fun trying to put these together, and we hope you keep coming back to join us.
That's right. Have a good day.
Everybody have a great day. See you tomorrow.